Welcome back to the lab. My name's Dr. Scott Diabolical, Evil Genius, and this is part 2 of how to make lightning. In this video, I'll show you how to design the prop to work with your haunt, and then I'll show you how I built mine. If you're just looking for the 8-minute how I did it video, I'll leave a link to that one in the description below. Let's get started. Before you start building, it's best to take a few minutes to design your prop. Here are my top 10 rules for staying safe and being successful. This is not a comprehensive list and should not be considered professional or legal advice. Number 1, stay within your property lines. Even if the neighbor says it's okay, if anything happens, the neighbor may not sue you, but their insurance company's lawyers will. 2, never cross roads, alleys, sidewalks, trails, utility corridors, or anything like that. All of these spaces have legal rights of way, which means crossing them always requires expensive permitting and probably requires an engineering survey, an environmental impact study, and the professional services of whatever your mayor's brother-in-law happens to do. Number 3, never attach anything to a public signpost, lamppost, or public utility pole. Remember, even if it's on your property, you still don't own it. That leaves you vulnerable to liability and lawsuits. If anything happens to that pole, or any of the equipment or lines attached to it, or anything downstream of those lines attached to them, whoever owns that pole will have lawyers that will try to make it your fault. That means you'll have to not only replace all of that equipment, but also cover all of the damages, all of the fees, and all of the labor it takes to replace all of that equipment. That could easily cost as much as a truck. Number 4, if your prop is going to be anywhere near people, it should be at least 12 feet above ground. Many people can jump to 10 feet. Most people cannot jump to 12 feet. And if your prop is anywhere near people, somebody will try to jump up and grab it. Number 5, plan for 70-mile-per-hour winds. This prop will blow around in the wind. You want to make sure that it can handle whatever nature throws at it. If you don't live in an area that is prone to 70-mile-per-hour windstorms in October, plan for them anyway. That way, if anything does happen to your prop, and it does happen to cause damage, your lawyer can argue that you've done your due diligence and overbuilt your prop, and any damages were the result of an act of God and not your negligence. Number 6, plan for ice and snow. Some of you may not need to worry about this, but I live in Colorado and I'm at 5,000 feet, and ice and snow in October is a real possibility. You need to make sure that if there's any chance you'll receive ice and snow, that your prop design can handle it. Number 7, avoid any sort of utility service that connects to your house or property, including but not limited to wires, cable, internet, gas, and especially if you have above ground power lines that connect to your house, do not connect to the pole that holds them up. Number 8, do not plan on attaching anything to a flagpole. Flagpoles are not strong enough. Number 9, do not attach anything to a single pole antenna mast. Again, it will not be strong enough. Also, avoid attaching anything to an antenna tower unless you are absolutely certain that your prop will not damage the tower or pull it down in a 70-mile-per-hour wind. And finally, number 10, do not attach anything to any of the pipes, vents, or chimneys exiting your roof. Most of those are made of very lightweight sheet metal, and none of them are strong enough to hold this prop up. Now that we know what we can't use, let's identify the resources we have that we can use. I've got the roof of the house itself, a large tree next to my driveway, a smaller tree on the corner of my property, a large blue spruce tree, and the scaffolding from one of the props I used for my Christmas show. Now let's look at the Light-o-rama controller. You'll notice there are two female plugs leading into it. One powers the left side of the board, the other powers the right side of the board. The board can handle a total of 30 amps, but in the United States, most household circuits can only handle 15 amps. If the board only had one female plug, it would consistently blow the circuit breaker of whatever outlet you plugged it into. With two input plugs, you can plug each one into a separate household circuit on different circuit breakers and draw the full 15 amps from both circuits without blowing either breaker. On the circuit board are 16 small devices known as triacs. A triac is simply a computer-controlled dimmer switch. Each triac is connected to its own female output plug. In the Light-o-rama world, each triac is known as a channel. Each channel can be controlled individually. Whatever you plug into that channel gets controlled by that triac. The triacs are controlled by the actions that you program when you create the sequences using the Light-o-rama software. I know you're anxious to see how that's done, but it is a very involved process, and so I'm going to save that for another video. Now that we've identified our available resources, let's draw them up on the whiteboard. Last year, I made my lightning look something like this. To support it, I ran my first polyester rope from the peak of the roof diagonally across the yard out to the small tree on the corner. From there, I ran my second rope over to the large tree next to my driveway. I ran a third rope from my fence up through the blue spruce tree and then down to the small tree on the corner. I attached a fourth rope to it and ran diagonally across the yard in the opposite direction to the large tree next to the driveway. Then I added a fifth rope from the peak of the roof out to the intersection. That added stability. I may have also added a few extra small ropes just for stability. Can't quite remember where those were, so I'm not showing them here. Another advantage that the Light-o-rama system has over devices like the Perfect Storm or the Pico Storm is that it has 16 channels to work with. At best, Perfect Storm has 2, and some of the more expensive Pico Storms and other options that I've seen have 4. Since we have so many channels to work with, we can break our lightning up into various sections. Last year, I broke my lightning up into 8 sections, each on its own channel, and I put the floodlights on a 9th channel. That placed the floodlights on the other side of the board, and so they're drawing off of their own 15 amp supply. Placing each section of the lightning on a separate channel allows us to animate each channel individually. That allows us to create different patterns in our lightning without having to run additional wires. We simply turn on different channels in different patterns at different times, and that makes the lightning appear to move. Likewise, we can control our channels so that the lightning appears to chase from one side of the yard to the other and only strike the tree if and when we choose. And since our floodlights are on a separate channel, we can control the flicker effect independently of any of the lightning bolt sections. Now I know you're anxious to see me start building this thing, But there is one additional consideration that we need to discuss, and that is where to locate your controller. Even though the box is quite substantial, the Light-o-rama enclosure is not waterproof, nor is it moisture resistant. This one is an older model and it does have a seal around the door, but my newer models don't. Even if you wrap the box in 3 trash bags with their openings alternating in different directions, and you hang the box up in a tree, enough moisture will still get in to damage your triax and short out your board, and you'll have to send it back to Light-o-rama for repair. Ask me how I know. I place my controllers in the garage. If you don't have a garage, try to locate your controller inside the house and run extension cords out to your lights. If that's not possible and you have to place the controller outside, try to place it in a covered location. Make sure that you wrap it in several trash bags and place it inside of a plastic tote and bungee cord the lid so that it stays shut. That does not guarantee that the board will not sustain damage, but at least it's something.
Release the Kraken! Bullseye! Woo! One of the best shots of the competition this weekend, ladies and gentlemen, right through the 5 on the 150 side. They've hit it twice today.
We made a hole in it.
Who told you I had a dog? I started my build by creating an anchor point high in the small tree on the corner of my property. I used carabiners to do this because I had them, but you could also use a soft shackle. I ran the main rope through the anchor point and then down to a lower limb where I could tie it off. I left plenty of slack on that end so that I could drop the rope in an emergency if I had to. I then ran the main rope diagonally across the yard, up over the ridge of the roof, and then tied off the other end to a fence post in the backyard. To protect my brand new shingles from any wear caused by the rope, I placed a small pad made from a scrap of carpet underneath it. The carpet has been spray painted black on the back side. For the second rope, I tied off to a low branch on the large tree next to my driveway, leaving about 10 extra feet of rope to work with. This extra slack allows me to drop the rope in an emergency and also to adjust the tension of the rope between the 2 trees. Then it was up through the shackle and over to the small tree on the corner of my property. You'll notice there are no lights directly attached to this rope, and that's for a reason. In many places, it is illegal to run electrical components directly between 2 trees. Trees can move around enough in a storm to overstress electrical components and possibly pull them apart, possibly creating a short or starting a fire. Rope number 3 tied off at the back fence, then ran up through a branch in the large blue spruce tree, and then down to the small tree on the corner. I then ran a series of small ropes in between the primary ropes, pretty much wherever it looked like I needed them. Most of the lights were directly attached to these. Now you can start adding lights to the ropes. When you do, I recommend starting at the farthest end of your lightning with the smallest branch. In this example, that'll be branch number 7, which will be on channel number 7. You'll start with the female plug end of your lights at the point where branch number 7 joins into branch number 6. Then run your lights outward all the way to the end of branch number 7, then double them back on themselves. Take the remainder of your lights and run them down the length of branch 6 until you run out. Then attach another string or 2, run down 5, then 2, then 1, heading back toward the origin point of your lightning. Once you have run the string of lights for channel number 7 all the way back to the origin point, you can attach a conventional extension cord and then run that extension cord back to the outlet plug for channel number 7 on your Light-o-rama controller box.
You'll repeat these steps for the remaining branches. Everything except for branch number 8. That's the actual lightning strike that comes down the trunk of the tree. That one we're going to do a little bit differently because we're going to attach floodlights to the end of it. The additional lights that run all the way back to the origin point from each branch act as extension cords for those channels. This method is not only lighter and cheaper than running conventional extension cords along your ropes, it also adds a free animation effect. Each time that one of those individual branches is pulsed on or off, the entire string is pulsed on or off, but only that string. When you pulse multiple strings in rapid succession, it creates a flickering effect on the sections that are closest to the origin point. Sections 1 and 2, since they have more lights, will appear to be much brighter and will also flicker just like natural lightning. And now for the part you've all been waiting for, or at least the part that you skipped ahead to. How to attach the lights to the ropes, and what all that galvanized wire does. I apologize that this is all footage of me disassembling the prop last year, but I'm trying to get this video finished as quickly as possible, and I simply do not have time to build the prop again and film it all. I think you'll still get the idea of what I'm doing. In places where the lights transition between one rope and another, I used wire ties to ensure positive connections to each rope. The galvanized wire is just sort of randomly kinked and bent up until it reached a shape that looked good. The lights themselves are then draped over the galvanized wire and sort of tangled in together with it. That whole mess is then draped over the ropes and sort of tangled and wrapped until it supports itself and it looks good. There really isn't a wrong way to do this, unless the lights don't stay attached to the wire or the rope, or you run everything in a straight line. Lightning isn't straight. And if things aren't staying attached to the ropes the way you like it, you can just kink up the lights and wire a little more and wrap it a little tighter around the rope. Maybe use a few more wire ties. Do whatever works. For channel number 8, we're going to do something different. Since channel 8 is the lightning strike itself, the lights that come down the tree, as well as the floodlights at the base of the tree, we're going to start by running an extension cord from the channel 8 plug on the Light-o-rama controller out to the base of the tree. Then we're going to take 5 strings of mini lights and twist them together, similar to what we did in previous years. Then, starting with the end of the bundle that has the female plugs on it, we'll attach it as close as we can to the end of channel number 5, but don't connect it to channel number 5. Run the bundle down the branch and then down the trunk of the tree, attaching it to the trunk of the tree by wrapping it with monofilament fishing line like we've done in previous years. Then we'll place our floodlights at the base of the tree. We want at least one floodlight pointing up into the tree and at least one floodlight pointing directly into the eyes of whomever is passing by. Then we'll plug both the floodlights and the bundle of mini lights into the channel 8 extension cord. Then we'll set up the remainder of the floodlights on channel 9 by running an extension cord from the Light-o-rama controller directly to them. These floodlights will be aimed directly at the house and will be used to provide the flicker effect that is associated with thunder. Now that you know how I built my prop, it's time for you to get out there and build your own. In the next video, we'll cover everything related to the Light-o-rama system and the sound system. How to set up the controller, how to connect the amplifier for the stereo, and how to program the sequences. Some of you requested a way to contribute to the channel, So I have set up a Buy Me a Coffee page that will allow you to make a one-time contribution using a credit card. No memberships required. And the minimum donation is only $1. That is as low as Buy Me a Coffee will allow me to set it. I'll leave a link in the description below. Thanks for watching.